Thank you, Zion. Thank you for inviting me to give the keynote. You, I really want to be there in person, but you will be happy that I stay at home because I've been tested COVID positive Saturday. So I'm going to talk about, something about biomedical natural language processing we have been working on for over 20 years. And currently, when I try to think about what I want to talk about it, I try to think about along all those years when we try to translate natural language processing into biomedical and the clinical domain. The situation is not as we originally thought because of the rich context around biomedical and clinical. So I give this title, but this is a little bit different from the context-aware system, where many of the Internet of Things and the device community talk about context-aware systems. It's a little bit different there. So the content discussed here is based on three thesis topics. We have been working on this. First is my own thesis back into 20 years ago, talk about corpus-based ambiguity resolution for biomedical terms using knowledge base and machine learning. In 2020, I fortunately got persuade my PhD student Kevin Peterson took this topic more and work on corpus-driven standardization framework for encoding clinical problems with SNOMED expressions and HL7 fire. In 2021, we have another PhD dissertation along those topics to really look at it when we talk about clinical natural language processing or biomedical natural language processing. How do we get the context and it to ensure scientific rigor and transparent become very critical. So the content present are based on those three dissertation work. So general outline, many of you in the text mining community know natural language processing on the context, but I still want to get into deep because where some of those are still not kind of, I know it, but not everybody know that. And second, I want to talk about natural language processing itself. Why it becomes so critical right now is due to the implementation of a learning healthcare system with the wide adoption of electronic health records across the globe. Third, I will talk about natural language processing in the context of clinical research. As I mentioned previously, when it comes to the actual context of clinical research, the natural language processing itself to solutions developed to have the correct context becomes critical. And lastly, I want to discuss the initiative we talk about, we need about open health natural language processing, where why open science is critical when we bring those technology into to help with health. So in the computer science side, information science side, in many different areas, we all talk about, text data. The target is text data. When it comes to biomedical informatics, people actually, whenever we talk about natural language processing, it can be anything along this diagram, which is nicely provided by Miner on the practical text mining statistical analysis for non-structured text data applications. This diagram shows very nicely says that biomedical natural language processing, when we mention that, it can be anything here. In the context here, we nail down to the actual natural language processing pipeline we've been talk about. And generally, we see there are 3 data sources come from for natural language processing. And this is generally the pipeline. You can have things from the speech recognition system. You can have things come from written documents, written text, which can be scanned through OCR technology. Most recently, not most recently, in the last 20 years, when we talk about text, it is actually computerized, digitalized text. So you don't need those written text OCR technology anymore. The Dragon technology, the speech recognition system, has been performed so well, so the text data become natural. But after you have text, that's not enough. You need to go down to the actual structure representation, to be used by many other applications for text processing. So you go through the pipeline of syntactic, semantic, programmatic, and the structure representation. Why I want to talk about it, because I want to get into the piece about semantics. Semantics, in general, understanding semantics has been challenging, but it is still okay with the technology advancement. But the programmatic is really getting us to the situation become very challenging. Programmatic is basically the words and their meaning placed within context, and it covers the relationship between words and people engaging in the conversation and the context. So we talk about context. So what exactly is the context? Actually, it's very philosophical questions. So in general, when we talk about semantics in context, in cognitive reasoning, we define based on the this work, this special issue, they mention about cognitive reasoning itself. The context is a theory of the word, which encodes the individual's subjective perspective about it. It is a kind of a partial theory, and as the individual's complete perception of the word is given by the set of all the contexts. When we talk about each language, when we generate each document, so when we generate, there a context around it. So that context is generally is approximation, and depends on who is the receiver of the message, who is the writer of the message. They can be quite different, and all those are under the even they are the same phenomena, but when we write about it, when we describe about it, we describe a certain level of approximation, and the right level of approximation depends on the problem to be solved. And why is it so important? And let's go back to the clinical natural language processing itself. When we generate a clinical documents, or when we have a biomedical literature, have an article, and that's the documents there, and the interpretation of that document require us to know what context that documents to be generated. But that context never truly explicitly accessible to computer systems to interpret it. And at a certain level, we can only achieve certain approximation. So the context play a crucial role in the whole thing about decision-making or data-driven science. This is the DIKW pyramid, where D is data, I is information, K is knowledge, W is wisdom. Just to try to think what language plays a role along those lines. So language can be in the data side. The data is, people have some observation, then can be a data points in a data layer. But the information about the data that's generally also described in language, and then go to the knowledge and wisdom part. You go along those lines at each of the DIKW. You got the language. So now just imagine on the data layer, human observation, you have a context of that human, which require you to know exactly when that human observe it, it's a subjective or objective, or is something, what context that data points is. Information, the same thing. In what context that description of that data and using the information pieces. So at each layer, the context become critical, and aware of the context is necessary for us to use to do text, to use data, text data for any kind of analysis. And then go back to how the language play a role in the whole humanity component. Language play a role in many pieces, and where the intelligence actually come from, we leverage the language to help us to convey innovations and to foster team science, teamwork, and the intelligence along each layer, the language play a role. For example, we say we have expert, and how the expert intelligence be displayed is through language. And then the intelligence can be observation of others, so you can learn from that. That's the data points, that's the experience. And it can be from experience of their own. But in general, when we generate the data points, when we write an article, all those things come from the combination of all those three, which in the form using language as the surrogates to capture that. So go back to history. This is not a new topic. Since the beginning of, have computer systems, and this is, we always want to processing natural language. We want to go through how do we formally representing language, how do we capture the language. So back from 1940 to 1960, we have the formal language theory, and using the finite state machines to process language. We go back to context-free grammar, all those pieces. In 1960 to 1980, we have two different kind of paradigm. One is using symbolic approach, the other is using a stochastic approach. But in general, those are based on those formal language theory and generative syntax passing algorithms. But moving forward from 1990 until now, the field has been dominant with the probabilistic and the data-driven models. And we have quite success in develop statistical natural language processing models for passing part of speech tagging, reference resolution. But when it comes to context or programmatic parsing, we're still not there. So my thread of the understanding of natural language actually come from Zilak Harris, where we adopt sub-language theory. The sub-language theory or distributional semantics, those line is reflecting is that under certain context, and when you define the context well, the language there can have some context specific type of structure, and the same time we actually can learn those things based on the data. And the semantics along that is just, it's context specific distributional probabilities around it. So the Carol Friedman, she was my PhD advisor. Back then, we talk about sublanguage theory constraints when coming to biomedical clinical language. But the constraints mainly is that those 4 constraints, and each of them is under the condition, under the specific context. Those things can be different, and it's a context specific. So the constraints generally guiding us to think about how to do sublanguage processing, especially clinical natural language processing or biomedical natural language processing. So in the clinical side, one of the things is, I think the dependency relationships, this is the critical. Basically, when these are the syntactic regularity dependency, which describe for the clinical documents. Then you have paraphrastic reductions. This is in the clinical documents, we generally want the form of communication to be very compact and to make it more efficient. So we have a lot of paraphrastic reduction. Such reduction causing issues because when you have several primitive sentences, they can form many different kind of complex forms. And the distribution in equality of likelihood, where there depends on the context, depends on the sub-language domain, they have different dependencies and have different likelihood. And so the last is a sub-language grammar, which is indicating in certain context, certain sub-language, you can only observe certain lexical entrance and certain particular statement types. The reason is important here is that the sub-language theory itself, when you translate, is that the acknowledges the context specificity of sub-language. And this is showing you from the 1994, the first medical language, not the first. So this is the from Sage describing the medical language processing system, where they show how using the formal language theory and how to formally representing the clinical data. And you see all those rules logic, the sentences is basically is that this 29-year-old girl who is known to be asthmatic for 15 years presented with this. So the system tried to process it, make it to be represented in the formal language grammars and through this kind of processing. And one of the challenges always face when before my PhD thesis, I also follow that formal representation side, which we formalize considering the lexical entrance, considering the grammars and all those. But there are so much variations. This is to give you an example. The one showing here is that this is a structured data, abdominal pain in abdomen, with certainty no abdominal pain not present. This is the code, very simple. But when you go back to text, there's so many ways to describe no abdominal pain. And this is showing some of the things which containing abdominal pain, all the different language patterns containing the abdominal pain with their associated frequency. The output here is actually the medley system's output. It's just to give you some idea. We can formally represent the language. However, there's so much variation here, and even the code itself, just one single code. But human language is so expressive and giving some challenge around it. And so so I look at it, I say, no, this is a challenge. And the other challenge was associated with the formal language representation is associated with word sensitive ambiguation. So we know, especially for abbreviations, we see some words have many ambiguities. That ambiguity causing significant challenge for processing codify the language to the right code. And so back in 2000, that early years, statistical natural language processing become quite hard. So we started to look at the language processing, word sensitive ambiguation, semantic processing, taking consideration of the semantic context. And the thesis is mainly talk about how do we leverage in those other context information to help us building a corpus, annotated corpus. And after the corpus being built, you can do building machine learning classifier to handle that. So this article shows some detail about it. So specifically, we're leveraging the unified medical language, which is from the National Life Medicine, which capture almost all the lexical entries and also code with rich what's going coded with the rich semantic relationships, concept relationships. So we use that knowledge base and you look at the conceptual relatives in the text. And so basically, instead of just look at the sentence itself, look at the whole paragraph and try to see if there are any concepts not ambiguous but appearing in the context. So we call conceptual relatives. And those relatives can help us disambiguate the term. So we achieve actually quite good performance to derive this, what we call a sense target corpus. And this achieve about 93% precision and 50, close to 50% recall. Basically, just based on context, the discourse level, the abstract itself, you be able to disambiguate, resolve the ambiguity associated with the abbreviations and other ambiguous terms with quite good performance. So it's just to illustrate how important the context in help us understanding the clinical, resolve the ambiguity related to ambiguous clinical terms. In 2020, we start also getting Kevin to work on this topic more. At this time, we try to look at the structural context. We noticed that the language and the standards always being a kind of together. When you impose some standards, then the expressiveness become less and the variation become less, then the language processing become easier. So we look at how do we try to, align the language in the actual clinical documents with the SNOMED CT and HL7, which are two standards. One is the standard terminology for problem list, one is the standards for the messaging. And I showing you this too, because this is just showing you before. This table, the table on the left, this is actually from the Sedge's paper about medical language processing, which is showing you almost all the medical classes, the description and the examples. On the right is more about the HL7 fire standards associated with the condition. The reason showing here is that, even they are probably 30 years apart, one is from the language side, trying to look at the, clinical settings, clinical concepts. One is from the standards, but they are, look like similar things to us. And here, for example, severe active leg pain with muscle weakness, all those concepts, severity, status, body side, you can see in the left table. Those things are actually standardized or captured before when we do language processing. So this paper just showing you, we actually try to including all the clinical problems occurring in the clinical documents with HL7 fire, leveraging, using the data, the language, analyze the language, and together with using the knowledge base to help us link those two. And so that the programmatic analysis, programmatic passing of clinical language become possible. And the conclusion of this paper is that we think we can successfully leveraging this standardization framework, leveraging the latest language models to achieve very good performance. However, I just want to bring you two things. One is that HL75, that's the standards. This is basically the context is already defined there. We try to map the text to a target context, target representation, target structure, and it become possible to do that. But without that HL7 file there, without that standards there, it can be quite challenging to talk about you know, clinical natural language processing. This is the high-level processing steps for the previous paper, which is talking about all the necessary processing steps for the for aligned to the HL7 fire. So you can see the processing steps go back to our traditional language understanding. Language processing, we do syntactic processing, we choose focus concept. After that, to be selected, we do UMS concept encoding and do relation classification, then we do the alignment. The reason I bring this here is that no matter at each step, we got the specific context to align us to. Without the UMS there, without the fire standards, we actually cannot achieve this processing. So the knowledge base, the terminology base, and as well as the standards give us a rich context, which is the semantic metadata target for us to align. And but the reality is that there are certain gaps. I want to bring you to the blue bracket here. This is the performance we achieved using those using BERT models and to do the relation detection, as well as the mapping. And we use the SNOMED CT, which is have rich relationships. So we use that to do to get that we call a weak label data sets. But the actual clinical text, the F1 score, want to bring you for severity, laterality, or clinical cause and finding sites. Those are generally, the terminology doing well, the clinical text align, the performance is relatively also good. But when it comes to things that involve reasoning and the inference, it becomes very challenging for the system to work. There's four relationships due to has interpretation following associated with those relationship types. We when we use in the clinical text side, when we use the formal SNOMED CT side, you see the performance in the relationship there. They're they're quite good because they are more structured. But when you come to text, it's become very low performance due to the variations, the real world situation associated with the relationships. So it's we can achieve certain level performance, but not to all the relationships we can discover in the clinical documents. Uh, so we did also look at it, with the advancement of big data with huge corpus available, with the deep learning technology. We see two things. One is the deep learning related technology, the size matters, and also we're using the language models, which is come from big data, big corpus. It also matters. So basically, this diagram just showing you the green dot is the convolutional neural network. When you have the training data sets size, when it's small, it cannot do very well. But in the other machine learning systems, as well as rule-based systems, they can quite stably go through the performance. So, but it all depends on we use the language models using embedding features here, using the word embedding features here. So two things in these slides. When we have large corpus, large raw corpus, the current technology be able to leverage that to representing the data semantics well. But when we using those deep learning techniques to actual classification task, any other task, we still need to pay attention to this training data size. If the size not there, they're not as, it's not, their advantage is not showing. So this has become, currently with the EHR, this we show in the healthcare become more data-driven healthcare system. And people talk about learning healthcare system, talk about digital health, talk about precision medicine. And no matter which way, when we go from the discovery to translation, implementation, delivery, we still need to go through the traditional clinical translational science type of paradigm to help us doing the right implementation. Noticeably, this is a concept of learning healthcare system where the point of care data become the data source for clinical research, and I have publication with results with clinical guideline give the best practice. So it become a loop. So now we talk about clinical text, clinical unstructured EHR, where the point of care data have a lot of unstructured data there. And so the secondary use of EHR, one of the challenges they talk about, those critical data elements, they are captured in unstructured. This pie chart shows you all the well-being health factors associated with well-being, where social behavior, environment, genetics, healthcare all contribute to that. But the healthcare only 10%. The majority of the data, social behavior data, contribute significant to the health, individual health well-being. But those data are not captured. And to use that, you actually need to either capture that, formalize to capture those information. But there are also challenges on clinical NLP researcher versus dissemination. This is a challenge we face in the domain. Basically, we finish research, but have we translate to help improve healthcare in the learning healthcare system side? We also face closed source and open source challenges due to the significant potential for using the EHR data for for many kind of usage. There are many companies coming to clinical natural language processing field. Meanwhile, we have privacy concerns and incentives for us as a clinical NLP researcher to translate to influence to real world healthcare improvement. So give you a simple example, which can be leveraged, like information extraction technology, which is, very low-hanging fruit when we try to use the technology for clinical research. This is showing you very simple. People just want to show, can we get patients who have silent stroke from their neural image reports, and we can get that. And because this is actually a silent clinical findings, it's not codified. If I want to study silent brain infarction and the stroke, silent stroke, so associated with the to get a cohort about it. And the only way for us to do is through the develop a information extraction system to get such information out. So the template is very straightforward. It's you have acuity, you have location, you have number, you have negation. The report is like that. So most of the most of the people who will be able to develop that. We think we can develop that very straightforward. And we did look at it, how information extraction be able to be leveraged for clinical translational research. This is a chart to show you the methodology people have been adopted for getting information from the clinical notes for their clinical and translational research for patient management or for any other use cases. We did notice the field dominant with rule-based approach, some with hybrid. and as a researcher, we tend to ask why this scenario. We did later figure out why we have some challenge to use deep learning technology or machine learning technology for those use cases. So what's happening here? So some details. We know we can use the clinical NLP for many clinical research through the process of feasibility assessment, criteria, study cohort assembling, um, to do data abstraction and to assess outcome. So natural language process on EHR can associate with each step of this clinical research pipeline. Um, and through the adoption of information retrieval technology as well as information extraction technology. And we did a scope review associated with EHR-based observational research study in part using NLP. So using some keywords, we retrieve about 1,300 articles talk about somewhere they're using natural language processing using EHR for observational research. Want to emphasize this is those articles who talk about actual clinical research. We exclude those NLP research. Um, what we found, there are many was using the number of articles retrieved at the end. We'll have 50 of them, and we have 66% are retrospective cohort study, 14 cross-sectional, and many of those studies are simply using the natural language processing for disease, 82% of them. So we see upward trend in the published NLP-assisted observational studies over the years, but there's still a gap. If you look at the number of studies identified using EHR and the number of studies over the years using NLP for observational study, you see the gap. We only have about 58 in 2021, which is talk about using NLP for EHR-based observational study. You have 2700 are EHR-based observational study. The gap is that when you have 2700 observational study, they have not used the text data. Oh, there's a significant gap there. Even we do clinical RP, we keep emphasize that there are 80% of the information in clinical in EHR are unstructured data, but you see the dramatic gap which we observed. And meanwhile, we also notice those actually using it, they have high variation reporting practice. So we are so happy to see those articles using natural language processing, but when you get deeper into it, uh, they are not describe their methods in much detail. A lot of them, just go through the middle, the top left. So a lot of them using rule-based system. Very few using statistical hybrid approach. You have 50 studies. They don't really have evaluation associated with their NLP system. Very few give you, how what's the model they are using. So you have 20, 40, 50, 80% and not really say what NLP they are using. 74% didn't talk about what they are actually using NLP targeting for what. So they don't have a normalization there. And 50-80% don't have the context defined. So basically, we don't know in what context that NLP system to be developed and at what context that system to be deployed forward. So it's significant challenges here, and we see high variation reporting practice. 14% of the study did not report NLP methods evaluation. 22% of the study did not report evaluation design. This is among the 50 articles we look at it, which do have some indicating to be NLP empowered clinical research. So we think very kind of moderate poor reporting of metadata in NLP in clinical research. Why is this important? Because the context of those NLP systems missing. Do you truly trust the clinical findings when the system itself not described clearly? I think we probably have need to look at it. There reproducibility challenge in the secondary use, and this is all the things we identify, and we see the lack of process transparency and quality control when we use the EHR data, and where the natural language processing is a part of the process to transform the data to a structured way for people to use. Um, so programming implementation challenge. So there are many contextual factors people not consider, and the associated NLP solutions, the context. There are many things impact that, and don't. This is just showing you there are many context factors when you do NLP development for clinical research. Because when the context is not aligned between the development and the implementation, there's a challenge of the trustworthy associated with the clinical findings. So don't want to get too detailed, because I will share this all those things are published. Basically, we're talking about where you truly want to use natural language processing for clinical research. We need to ensure the task itself to be defined clearly. That clear definition is important because to mitigate potential contextual heterogeneity factors associated with the system. And then the development itself, of course, we can use many different approach. So far, you can use rule-based approach. You can use the context-aware language model approach. You can hybrid. You can do those. Many of the things need to be considered. One is robustness. Second, the possibility generalizability. Then performance bias need to be considered. For the deployment, and no matter how good you are, you're still going to have errors. And how do we ensure all those factors to be cataloged? This is just showing you error analysis is the critical component when we deploy a model. I think I'm have quickly run out of time, but this is just talk about what we believe. We think for clinical natural language processing, for biomedical natural processing, all those things require us to be taking some kind of social approach, because each of us
Can you
can
hear me,
advance.
Hongfang?
Yes.
I apologize. This is a friendly reminder. I think we have we like to wrap it up in 5 minutes, if possible.
Yes.
Thank you.
So just to quickly go through. So this is an Open Health Natural Language Consortium. It's a consortium established in 2009. with the Mayo Clinic and IBM collaboration with the system um, released there. One is the CTEX system, the other is the IBM MedCat system. Those two systems has been help you know moving clinical RP to a lot of real world use cases. And we've been working on this in 2017. We've been trying to see how do we be able to um, creating a partnership and a collaborative work to help us, for example, first to enable multi-site studies to improve our algorithm development. Secondly, how do we generate synthetic text data for people to be able to use the data uh, for for training purpose, and how do we performing using the NLP for computational phenotyping. And last, how do we show the value to the broader community? And this is 2022, which is the things we're showing before. We think we needed to adopt a right to fair principles towards translating the natural language processing for real world implementation, where the privacy preserving it needed to be take consideration. It's no longer the way in is that giving me all the data, and that's not going to work in the clinical context. And we also needed to make sure we are engaging domain experts to define the context clearly and to build a trustworthy system to be able to translate to make the scientific to make the process transparent, ensure scientific rigorous. And our effort mainly is looking develop many tools to support in that process. Don't want to get into detail, but it's so critical. Is that we need a realistic approach, and we needed to adopt an open science approach to ensure the artifacts associated with clinical RP as well as the associated clinical research need to be fair. We also needed to ensure there's implementation to be transparent, implementable, and external reproducible. Those is so critical for when you use the natural language processing for clinical domain. Um, don't want to go to detail, but those are the underlying articles we have been driving us to move this forward. And we welcome the team science approach towards it, and make sure a trusted process need to be deployed there. And this is also called for open science collaboration. This is showing you through one of the latest effort, we try to have a crowdsourcing development environment to ensure people can share what they find and share their NLP artifacts to move towards the deployment. Um, and I think I go through this. Just want to highlight this tool, which recently developed by the team, try to show a serverless privacy preserving type of corpus annotation tool. Basically, all the documents are behind your firewall, and you can do annotation straightforward with all the corpus to be with all the corpus annotation tasks to be able to be shown in one tool. Um, this is what I see we should moving forward in the clinical domain. We do want, us, especially we position our team to be in the middle, to be a translator. We have a rich clinical research community, but we also have a clinical translational science research community. how do we solve a bridge between those two to ensure we work together to ensure the translatability of the NLP for clinical and translational research, and for building the learning healthcare systems. I think that's the last slides. And I think I'm open for questions if there's any minutes.
Thank you very much, Hongfang. Let's see if we have questions from the audience. So you asked, I have a question. Can you hear me?
I can hear you.
Okay, so you mentioned, thank you again, fantastic talk. You talked a lot about clinical natural language processing, and talked about one study you did, scoping review, where you showed that most of the studies using NLP are using rule-based NLP. Is that still the trend, you think? Because you look at the studies over time, but I'm just
Yeah,
wondering,
that
in recent years, is rule-based system still the mainstream method used in clinical NLP? And if so, why? What are the challenges you think are for machine learning based methods? Is it not accurate enough? Is it too difficult to explain to the users? So on and so forth. Thank you.
yes, that's still the trend. This is to go back to the slides which we emphasize privacy preserving, trustworthy. So specifically, it's different from the literature domain where you probably have the text available. In the clinical domain, we don't have large clinical text available in the public domain. And we don't know the context of those language. Unless your single institution have NLP experts, those text data cannot be fully leveraged. So we did try to, most of the system, as soon as you come to specific context, specific task, they're not doing well without training, right? Because the system, different from literature domain where you already see the text. In the clinical domain, when you have a system developed outside, never trained with your local data, you actually they cannot be directly used. But how many when go which way is easier to develop for actual clinical information extraction, the domain experts actually like the rule-based approach better because they can understand it, they can interpret it, they can trace back, so they trust the data that way.
Right.
I think unless one day we have all the data in the I still don't see this will coming if you take privacy deep into your heart. So
Yeah.